All right. Well, welcome to today's National Soil Survey Center webinar. My name is Sean McVeigh, National Training Coordinator for the Soil Science Division, and host with West Virginia University for today's webinar, USDA CarbonScapes. This is a collaboration between USDA and West Virginia University to provide an easy-to-use web application to educate and answer questions about USDA's inventory, modeling, and mapping of terrestrial carbon. Please take a look at our webinar layout. You'll see we have a control panel on the right side of your screen that allows you to chat with the event organizers and ask questions. You receive the webinar audio through your device's speakers or by using your phone. You can unmute your PC audio by clicking on the microphone icon. Please be mindful of background noises in your work area and use your mute button until you are ready to speak. We'll handle technical difficulties the best we can while hosting the webinar and interact with our presenters to answer your questions during verbal Q&A periods. This webinar is being recorded. I want to thank Sharon Waltman for bringing this webinar idea forward and for being here to support our webinar and introduce our presenters from West Virginia GIS Technical Center, Kurt Donaldson, Manish Sharma, and Frank Lafone. Sharon, I'm going to turn the webinar over to you so you can introduce the topic and our presenters.
All right, thank you very much, Sean. I appreciate that. All right, I think we're going to mute everyone that's online and we'll begin. All right, my name is Sharon Waltman, and I'm a soil scientist with the National Soil Survey Center Geospatial Research Unit, which is located on campus at West Virginia University in Morgantown, West Virginia. And I have with me today my colleagues, and I'm going to let them introduce themselves so you get to know their voices here. And there are three of them, so Kurt, let's begin with you.
Hello, Kurt Donaldson with the West Virginia GIS Technical Center here at West Virginia University.
Frank Lafone with the West Virginia GIS Technical Center. Manish Sharma with West Virginia GIS Technical Center.
And today, thank you all. And today we're going to share with you some of our work that we've been involved with for about 2 years now, called a project called USDA CarbonScapes. So let's see here. I go forward. Oh, here we go. Okay, very good. All right, USDA CarbonScapes. This is a project that is kind of far-reaching, and it's been kind of a second try at a project maybe some of you helped to contribute to over the last almost 4 years. It's an effort that we hope that perhaps will kind of set the stage for how USDA Enterprise Data Center can collect together a lot of all of the essential natural resource information that is needed to make reasonable carbon estimates for the terrestrial carbon ecosystems. So our broad goals are to basically bring USDA scientists and models and along with their data together for ready access and give them ready access to our national digital map layers to be able to make full use of these. With the goal of improving our assessments of the soil plant carbon sequestration to estimate greenhouse gas emission offset potential from our ag lands that we're charged with managing and supporting through various modeling scenarios. And in doing this, we're also trying to embrace geo-platform principles that our Office of Management and Budget Federal Geographic Data Committee is promoting. And we are using a lot of the guidance in our organization of these data that you'll see today to try to achieve that. So our goal here is to make the most, be very efficient in our use of staff time and resources in managing these data because they are quite large and fall into that big data category. So CarbonScapes, some history. There was a project that was funded in 2010 and 2012, and it was conducted by a private sector group and Colorado State University and Critigen was the name of the company. And they were able to prepare something called a carbon data visualization tool. But when this tool was brought forward, it was felt to have several deficiencies that needed attention. Some of these were included. It's too complex. It's not easy to use. You need GIS skills to decipher the interface. No simple reporting tool, and no data download capability. So there was a decision made to seek out a university cooperator to help provide enhanced user interface for this product. And West Virginia University and the GIS Technical Center here in West Virginia were interested to take it on. Dr. Jim Thompson is our soils contact for that. And we've been working on this project through a CESU project between 2013 and 2015. And we were just awarded a cost extension that will run until August 2016. So this is some of the results. Early in our study in the 2013, I think we conducted some focus group information to gather inputs about what folks didn't care for in the original tool and what they'd like to see. So based on the CarbonScapes survey results there, we had quite a broad group of individuals, mostly folks from university, other federal agencies, and our own agencies within USDA, on the focus of their need for getting at terrestrial carbon information that we all work to prepare in our soil survey program and related programs. The original tool was basically, you can see the red arrow at the top there, it was called the Advanced Data Viewer. This was it was developed with a Flex API and SQL Server, and it was quite a big effort. That we basically just took that data set, stood it up, or took that application and stood it up here at West Virginia University along with all the original data sets and so forth. So that's quite an achievement for the group here to have stood those up. These are big national data collections of mostly conterminous US data layers, several of them. However, we recognize that that software, which is going on 5 years old now, needs to be brought forward. So that was our became what we call the Explorer in USDA CarbonScapes. And the survey results thought that we needed two new kinds of things, a public site, which became the Atlas. And this aggregates a lot of the detailed information. And this work is done in JavaScript, and it has potential for being accessed on devices. In addition, it was difficult for everyone to keep straight all of the data that was being ingested into this. So we added a data or a model and data clearinghouse application, which we called data. Let's see here. So this is what we've come up with. It's called USDA CarbonScapes, and it's hoped to be a national look at carbon landscapes and also a central location for all of those scientists and staff and cooperators who are involved with USDA carbon inventory modeling and mapping of the terrestrial biosphere, so that they could have a central place where people can come and find out information about it. We don't really intend to reuse any of their information aside from consuming it and making it readily available and useful. So this is a work between, as I mentioned before, Dr. Jim Thompson with the Division of Plant and Soil Sciences at West Virginia University. Jim is not with us today. I think he's in travel status at the ASA meetings. And our West Virginia GIS Technical Center here at West Virginia University. This staff manages and maintains a good deal of West Virginia GIS data for the state of West Virginia. Just a quick look, here's the front piece from our Quick Start User's Guide, which you'll find in the About section online. You'll see here we have the data and Atlas and Explore sections, and we also include a Learn section, which we explain what's going on easily and quickly, and also have potential for linking to all other educational materials related to carbon coming from our sister agencies and our own agencies. So again, our goal here overall is to provide a useful and easy to navigate web application that helps to educate and answer questions of our stakeholders about our USDA inventory, modeling, and mapping of in the terrestrial biosphere within that landscape. So basically we have these three main applications. The Atlas, and that summarizes specific carbon pools, accesses the carbon pools via a zip code. We offer flexible reporting units that can be in international units or English. We have carbon mass expressed in energy consumption or sequestration terms. We also have the data, which catalogs and links users to USDA terrestrial data and model resources, and also finds your way to data.gov and finds information there readily. In addition, the Explorer, this is the original piece to the project, has been enhanced and several new functions have been added. We can query and analyze various models and data layers. We can create maps now. That's a new addition. We can share locations or bookmarks through geospatial links. We also have added the function of being able to extract the data, so you can clip out and take a small bit of the data away with you if you wish. For the advanced user, we provide now administrative login, so you could do further kinds of queries and inventories and more scientific level overlays and modeling. This would, I think, would be the kind of vision for the future in enterprise data centers for big data kinds of computation and model runs if the future will allow that within USDA. So here we have a view of what the Atlas interface looks like. Here we can summarize. Right now we're working principally with just the grid ergo, soil, carbon. These are rather conservative, but we have summarized them at the county level, watershed level. We have the 8-digit as well as 12-digit. And also we've used major land resource areas or our de facto ecoregions. Others can also access, we can use zip codes to find the local to do this, and we report the units in both carbon and CO2 equivalents in a variety of choices and units. Carbon mass is also expressed in energy consumption or forest sequestration terms. So right here, this is what the screen will look like. We'll give you a little demonstration here shortly. On the right, you'll find there's a little short instruction on how to navigate. You can enter a zip code at the box at the top. You can also choose your geographic area there. You can choose counties or watersheds or ecoregions. You can choose the kind of carbon pool. We'll show you soon. We have places plants above and below ground. And we're about to include the forest inventory analysis from 2014, I believe it is, soon in this tool. Today we'll show you only the soil carbon estimates. Here is the slider where you can choose whether it's stock or and here's an opacity slider to let you look through the map to see exactly where you're at in the landscape. This is where you can choose carbon units as well. In the data section, this is basically a quick inventory of the kinds of data we have. We're still building out on here. I think we only have 4 basic entries right now, but it shows you some of the quick links to find data.gov and these data sets. I'm not sure if any of you have tried to use data.gov, but it's not so easy to find even your very own data sets there. This helps you link through directly. It also gives you links to the web services that are used here and lets you evaluate whether or not you like to add them to your own local GIS center. These are public. I think this is a gridded Surgo 2014, and I think this may be our only public web service we have right now, so you can check that out. We also have forest inventory and analysis and a few others that we'll demonstrate. Let's see. And also we link back to our other USDA websites to get full information. The Explorer. This is, provides more advanced users, in-depth tools to visualize and analyze the carbon models. We'll take a look at that. And here now we are able to create maps, share those geospatial links, and also extract GIS data. Here's a little bit of a view of what that looks like. The analysis tools you'll find are in the upper left-hand corner of the screen. The navigation tools are found on the left-hand side of the screen, and the sharing tools are now in the upper right-hand corner of the screen. What we're looking at here is this theme happens to be the carbon calculation tool summarized at the county level, and the legend is shown over on the right-hand side here. This is expressed in grams per square meter right now. Bluer colors are lower numbers for forest carbon, and the upper numbers are the higher numbers. This is another shot from our Quick Start Guide, which you can find in the About section. We have here the analysis tools detailed in the low left-hand corner. navigation tools in green in the central part at the bottom, and the sharing tools are on the right-hand side, lower right. For the expert view, this will involve requesting and getting a login, but you can get to a lot more of the data that we've amassed since 2010, and we're looking to have new information contributed too. We do have a few climate change scenario information here, but we really need to have that refreshed and brought forward with additional information. Let's see. So now we'll start a demonstration here, I think. So this is the front page. You'll see that their atlas is on the left. Explore and data are offered right here. In addition, we have a navigation bar at the top for the home, atlas, explore, data, learn, and about. So let's start with the atlas. We're given this, and this is where we're going to look at, as my colleagues call, the more curated view of the data. It's been pre-summarized and ready to be used and made useful. And I think I will enter a zip code for someplace in Iowa, I hope. And this is going to take us to Polk County, Iowa. And I will just monitor the opacity a bit, and you can see this is the location of Des Moines is where we're looking at that part of the world. And let's see. We have now just the right-hand area has shown us a little diagram that's appeared, and these are county averages now, and the carbon pool that we're looking at right at the moment by default is the upper meter of soil, and this is based on the 2014 GSERGO calculations summarized across the entirety of the county. In this case, I think it is Polk County, Iowa. So according to them, according to this guidance here, we have about 204 megagrams of carbon per hectare showing up based on those estimates. The other pool that's available right now is the 0 to 30, which we're calling topsoil, and that's showing about 90 megagrams of carbon per hectare. The upper bar here shows us the actual value in megagrams per hectare. This is our default number. And the lower bar will show us the rank of the county within the lower 48 states. Right now, our data sets are confined to the conterminous U.S. So this county, Polk County, is in the 70th percentile. So that means that 70% of all of the lower 48 counties happen to have less carbon than Polk County. All right, so let's take a look at the mass of carbon found in that Polk. Let's go back to 100 centimeter depth. And so just how much carbon is that? Well, according to our estimates, and we know that our soil survey estimates are rather conservative, we've calculated here about 28 million metric tons of carbon are present for Polk County, Iowa. So what does that mean exactly? That's a lot of carbon. And so we've gone to the EPA clean energy conversions, and we provided you some translations of those. So 28 million metric tons of carbon in the upper meter in Polk County, Iowa would be equivalent to about 21.6 million passenger vehicle emissions per year. It might also be equivalent to about 14.1 million home energy uses per year. And the number of acres of forest to capture that amount of carbon in 1 year is about 84 million 2 acres. So that's a lot of carbon, isn't it? Well, let's take a look at some other geographic areas. We can also do watersheds. Let's zoom out just a little bit here. And let's choose this one. Here we are. We're in an 8-digit huck called Lake Red Rock. And so here, now we can look at the summary by 8-digit hucks, and we have about 88 million metric tons of carbon. Or we can switch back and look at the stock numbers, the concentration of carbon, and here we're looking at about 145 megagrams of carbon per hectare. If you're not very comfortable with those units for the stock, we can offer you some others. Perhaps you'd like to look at U.S. tons per acre. So we can look at that, 65 U.S. tons per acre, or perhaps pounds per acre, if you like your English units. That's a lot, 129,000 in some. And also for the mass number, we offer you some other choices as well. Let's see here. I kind of like this one, train cars of coal burn. That's kind of an interesting one, about 1.7 million. That's a lot of coal burned. And I think now we have trains. I think we assume 100 cars per train on those. So interesting, some different choices here. It's one of the, you can also do CO2e or carbon dioxide equivalents are their choices as well to make it easier to understand. In our focus groups, we found that we had such a wide audience that we had many, many preferences for units. So we put them all in there. We do make a default, though, so we don't make you choose right up front. All right, so let's see. We can also do ecoregions. So let's choose this one. I think one of them is that one of my questions to ask was, so exactly how many acres of forest would it take to capture all of the carbon in the Des Moines lobe or MLRA 103 and in the upper meter, and it looks like it would be almost 5 billion in 1 year. So that's a tremendous amount of information and carbon offered there. All right, so where does all this data come from? Let's take a look at the data tab. Here we have some of our choices. We've got the gridded Surgo listed. We've got forest inventory and analysis listed. We've got the crop data layer from NAS, USDA, and we've also included one model at the moment, the Comet Farm. And let's just look here. We'll start at the bottom and work our way back up. We've provided the links so you can go straight into data.gov and follow with the OMB type metadata that you need to know about. The crop data layers, likewise, we can go straight into data.gov to find that. Same thing with the FIA. And also our gridded Surgo. So this was given us into our formal data searching capability for our federal geospatial data assets. It's OMB is asking us to do. And then we can also click here and quickly open it up in Explorer. So we've got here, this is the 0 to 100 centimeter depth soil organic carbon showing up. And if we want to look at all the different layers, we have a basic reference layers, we have some model scenarios, we have under data, we have soil survey data, and we have the organic carbon turned on right now. We also have crop change and crop land cover data. We have all kinds of model results from the coal model, from forest inventory analysis. This is some whole earlier work. We're getting newer information, and we'd had hoped to have it today, but we're not quite ready to share it yet. And also some PRISM data there too. So what can we do with some of this data? In addition to the work that we did prior, let's see, we can look at the legend for sure. And these are expressed in grams per square meter, so the darker colors mean higher concentrations. I will put away the layers, and we can zoom in. And we'll try to see if we can find Iowa. If we want to zoom in there. Maybe the Des Moines lobe, if we wished. And now we've added a few new functions. So now it's made much easier. We do not, the original application required a login. This is public. We don't need to do that any longer. We can share this link quickly and easily. You could drop it into an email to a friend or a text or whatever, or just drop it into your browser and share the exact same view with a colleague if you wished. So we have both of those available. Close this one. We can also print, make a small map if you wish. We just call it NSSC. And I think our default is to create a PDF. So we'll see if we can get that to go. Let's see if we can make it create a map for us while we're talking here. And also we have the function, I'll show you in a short moment, capabilities for exporting the data. You could take out a small amount. I don't believe we've set a limit on how large that can be at the moment, but I'm sure it won't be a very large area. So here, when it's ready, you can click here, and the PDF will present itself. So you will be able to have whatever you have organized into the Explorer website along with the legend and some information about when it was created and where it's from. There's also the export tool here, and we can choose whatever the data layers are that we're targeting here, and you can use one of these tools to extract the area you're interested in, and it can be downloaded in various choices and for vector and raster. So let's go to back to the atlas for a moment. And I'll go back to my zip code. And I'd like to point out that if we wish to, if you would like to learn more about the carbon stock or the mass information, you can click here and it will take you to the Learn section. And Dr. Thompson and his students have prepared this little section to explain some basic principles about that, carbon mass and stock. Let's go back. And we think that this could be quite a nice place to, launching place to link to a variety of other educational materials that all of our agencies have put together related to carbon sequestration and management of carbon in the terrestrial carbon landscape. If we click on Learn by itself, we will come into this with a very simple, approachable kind of a way of dealing with the overall carbon cycle, and helps to enter in for easier to understand public and for students to find out more about how important the sequestration of carbon is in our plant and soil materials in the landscape. Most of our guides that we've been looking at that are offered on the website are really quite highly technical and written for professional journals, and which are very important, but often it's not very understandable or useful to the common citizen. So we're very interested to offer a more of a approachable entry point here. And finally, the About section. And this is where I've talked with our group today. We would love to have you offer some user feedback. There's a flyer, a two-page flyer. There's a quick start guide. I'll show you some of that in a moment. And then there's the overview videos on the CarbonScapes itself, Atlas and Data, and Explorer are all up on our YouTube videos. So those are, I encourage you to check those out. So I think we'll go back to the PowerPoint now. And talk about some of the work that remains and how you might be able to help us with this. We have this work here, and some of the input we need will be to help to get a little membership into some focus groups, but some of the remaining work that we'd like some input on are how we can work together to add more stock and mass carbon for the plants above and below ground, and create more total carbon estimates at the county's watersheds and major land resource areas or other ecoregions if desired. We are working actively right now with FIA within the U.S. Forest Service, but we really do need some of the crops and other kinds of carbon estimates. We want to add more in the contextual how and refine the atlas so that it would be more accessible and useful on mobile devices like iPads. Actually, it doesn't do too bad on an iPad right now, but iPhones and so forth. Future work for the Explorer. We want to add the updated inventory and model resources, get those all up to date and linked properly to their authoritative sources. Review and update the tools and functions based on the feedback from users. Think about, well, actually create an analysis and design document for what it would take to convert this into a JavaScript or more modern programming too. And also maybe it would be required to convert this into a more modern JavaScript API if it's to be accessible on mobile devices. Within the data, we want to organize that a bit more so we have the basic pools. So if you just click on soils, you get all the different kinds of soils linkages that you need, all of the vegetation linkages, so on like that. We also want to work to prepare a better content management system for our metadata so it can be more easily fed into the data.gov formats and templates that are required by OMB. In the Learn section, we're really eager to incorporate links with all of our existing agency educational materials, on models, on inventory data, on all kinds of things. And let's see, again, we'd like to engage some focus groups, so if we have some folks who'd like to join us, please send us an email and so forth. In fact, what we need from our viewers today, and we're very happy to have many of you with us today, we'd like to help to identify and contribute the authoritative data for models and results. And as I mentioned, we're already working with U.S. Forest Service, Forest Inventory and Analysis, and we also have the point data for the PET-ON data for soil carbon estimates for 0 to 30 and 100 centimeter. And so what we're needing, what we're lacking are those estimates from the crop sources, rangeland and so forth. So we're looking for some contributions from our SEEP project, our Conservation Effects and Assessment Program, the Rapid Carbon Assessment Program too. Those data would be very useful and helpful. I don't know that they're quite ready for contribution, but we certainly would love to have them there. We'd like to use web services and wherever they're available for these rather than housing our own copies of those services. And we need membership in our focus groups, as I mentioned. So you can send emails to our points of contact. I'll share with you shortly if you'd like to be part of that team. And we also need some help from our public affairs folks. If you have some really good ideas about different ways to present this work, we're very eager to know about it. And we really, our whole overall goal is to raise awareness about USDA CarbonScapes with the potential for building on our geo-platform goals. We're trying to get ready for some big data planning and reporting to help support our greenhouse gas inventories. We really need this, and we need to let people know how we do this work more readily. So I'm looking for sponsors to help raise this project up to our USDA Office of Chief Information Officer. So again, thank everybody and encourage everyone to go to the About section. And if you click on the user feedback, a short survey will come up that says, what do you like about USDA CarbonScapes? What don't you like? And if you'd like to leave us your email or not, you can certainly do that, but you're not required to. And let us know what you think. Or you can send me an email message, or Dr. Mike Wilson, who's our National Leader for Climate Change. You can send one to me, Dr. Thompson, too, Dr. Jim Thompson, or any of our technical contacts if you've got questions about the work they've been doing for us here, Manish and Frank Lafon. So with that, I think we're ready to review some questions.
So we have 3 questions. If you look at the chat window.
All right, we're looking at the questions now. So let's see, what do we got here? Alrighty. All right. Frank, you want to read the question?
Yeah, so
Thank you.
this is from Sandra Arrego-Caro. I'm sorry if I mispronounced that. What kind of parameters will work for your soil carbon measurements? We are planning to work with soil representations and organic matter measurements.
Oh, respiration. I
Sorry,
see it. Yeah, I'm looking through my bifocal here too. Well, right now we're working with our soil survey inventory information. So if you have any kind of rates, any carbon flux measurements and so forth, those would be quite useful, I think. So if you're doing any respiration work and that kind of information, if you can have some kind of information by land cover and by a certain kind of ecoregion or region of the world, by climate, by time step, that's what we're after. I assume that you're doing plot work, maybe? Well, maybe we can unmute to here after we go through all of the questions. Follow up with that one too.
And then Sean McVeigh has a couple questions. What about modeling the potential C increase in soils? The maps show what is there now, but what about potential maximum storage in soils? And what would it take to make that shift?
Oh, those are good questions. Those are some of the same questions that we got from the Office of the Chief Economist with USDA when we gave this presentation to the Global Change Task Force. He says, I'm interested in the flux, I'm interested in the change. So how can we get to that? And I believe when we, USA and USDA, prepare our greenhouse gas inventories, we do the modeling using a lot of century-based models is what I understand, and use a lot of these inputs, just like the SEEP people, I think, are also using a variety of models, which include some century-based models to make estimates. I think what we can do is use real climate data to help us figure out what's going on now, and then also look at some of the climate change scenarios. We have a few of those runs with I think it is Comet Farm or Comet Descent in the CarbonScapes collection right now, which were prepared by the Colorado State folks. But I think we have some other data that we can look at, and those are reported each year as part of our EPA greenhouse gas inventories.
Okay, Brian asked, do you foresee the capability to calculate how much carbon could be added through soil amendments, i.e. compost, biosolids, and biochar?
Yeah, pardon me. I think we could actually. Again, for large land areas, it might be we'd have to make some assumptions and maybe model it forward. And I think when you go into the Comet Farm site and so forth, the individual landowner can control some of those input parameters and assumptions and make some estimates of what those rates might be. But for these large landscape areas, we need to really do some broader kind of land cover change kind of modeling scenarios.
Mindy asked, do you foresee including carbon data in the web soil survey feature so that it would be possible to upload an area of interest and see what kind of carbon mass it contained?
Ooh, that's a good one. Can we do that now, Frank? Can we upload them?
The short answer is the tool is not currently configured to allow that to happen.
Mm-hmm.
Is it technologically possible? Yes.
Mm-hmm.
But we haven't done that.
No.
It would be a feature that could be added at a later date.
Yeah. I think that's true. We could do, we've started to work on some predefined regions right now, but I think that could be a possibility. Right now we do this carbon calculation for the gridded sorghum once a year. And again, it's based on solely our inventory data. We're not making any assumptions about anything. So those data could be offered within the web soil survey, and it is a pretty simple calculation to multiply the carbon stock number times area to come up with the mass numbers.
And then finally, Sean asked, what about incorporating carbon in our non-terrestrial soils? Subaqueous?
Subaqueous, okay.
Subaqueous, sorry, I'm not a soil scientist. Subaqueous soils, both saltwater and freshwater subaqueous soils.
Well, that's a good question, Sean. I think we chose terrestrial here because we needed to draw the line somewhere, but certainly I think we could include the subaqueous information, which are for my computer science and geographer friends here, are mostly the soils that are beneath the tide as well as within wetland areas, fringes across the nation. So those are kind of sometimes underwater, so we would certainly want to include those, and I think as part of our soil survey we do include those estimates too. That's a good one. Any more questions?
That's all the questions were submitted so far. If anyone has any other questions, please submit them now.
I can switch on.
Yes, and I think we can actually unmute the microphones if anyone would like to ask a question verbally too. All right. Okay.
Sharon, this is Joel Brown.
Hi, Joel. How are you doing?
I'm doing just fine. I've got a question for you on this. Have you guys got a way to calculate uncertainty associated with these estimates?
Sean, I'm sorry, Joel, we're getting an awful lot of feedback. I think we're going to have to, can you type that in the chat maybe, or send me an email? I think we're going to have to mute it. I'm sorry.
All right, I've got a long statement from Clay.
Okay.
Is Comet Farm the tool that we could use to estimate the amount of carbon sequestration that takes place based on practice implementation in a region? Is there a tool that will allow us to show what the estimated carbon sequestration rate is in a given area and avoid emissions as well when we do certain practices? Say, if 100 acres in Oklahoma are converted to no-till using EQIP, can we show what the resulting carbon sequestration and emissions avoidance rates?
You know, that's a good question. I think it's possible, but I don't know what the logistics would be, because usually when we do Comet Farm, my understanding is you need a lot of local inputs for individual conservation systems, assumptions, and so forth, but I think it's certainly possible. Oh, good. Joel's typed it in. Let's see. What does Joel say?
Joel says, do you have a way to calculate the uncertainty of these estimates, especially across changing spatial and temporal scales, which is a great question.
Oh, yeah. Well, right now, I guess we can just say that we have high and low ranges. The methods that are used for this particular calculation are those that use the representative value only. And I think we can probably average those, I mean, give the high and low estimates on those if we need to. And that would probably be about as good as we could. Once we get a lot of more of our point data, that is one of the things we can add in our head-on measurements, actual measurements in the field, and we do have those that we can contribute. Those, of course, span about a half a century or better in time as well, so it's a kind of a moving question. Right now, I don't have any good answers for that one right now, Joel.
Mike the Soil Guy, which is a great name, some good questions. Who is this tool designed for? If conservation planning, do you think that you are overreaching with the data?
Well, this tool is designed for anyone who wants to know how much carbon there is in the broad landscape. So I guess it helps us to think about the landscape as a whole. For conservation planning, I certainly would recommend that we work with the local models and so forth in there, but certainly we have to think about the complete interaction of those decisions within a broad basin or a broad ecoregion or the nation as a whole. So I don't know if we're overreaching, because I'm using soil survey information right now, and I will be using statistical information from forest inventory analysis. I think we will push it as far as the statistical reliability will let us. Certainly we use detailed soil survey information for conservation planning right now. Okay, any others? That's lots of good questions. Maybe we're done.
Should I unmute again? Yeah.
Okay, go ahead. We'll try to unmute one more time. If anyone has a question, we can try one more time, a verbal question. Right. If not, I think we're done. And if you would like to follow up, please send an email to sharon.waltman@usda.gov or mike@lin.usda.gov. You can see Mike there. And we'll be happy to try to answer them as best we can or find the right resources for you. Again, thank you very much for your time, and we appreciate all of your questions.